Okay, so today I'm going to be going over a board, and it is finally the season within which I need to turn on my air conditioner. So you probably hear more of the air conditioner than you do of me, unless the nice microphone and the very, very nice noise removing plugin is doing its job. So today we're going to be going over an 820-3476, and this is going to be a little bit of a confusing one because it's dead. And it's dead for a strange reason that I can't figure out. I can barely hear my own voice over the noise of this fucking air conditioner, but it's you got to see. Well, let's see if I can get it to where you can see the joke of an AC setup I have in my office. This camcorder is pretty stationary because it's it's on a stand and all that, and it's got wires going to it. But let's see if I can get it to where you can see the clusterfuck that I have going on here. So this incomplete shit box little restaurant looking shit. So that's my air conditioner, and I have this vent and this thing going along the ceiling until it gets to that room, and then that's where I sit. So it's pretty fucked up looking, but yeah, it's loud as hell. It's annoying as shit. So let's see if I can get this back to a good camera angle for myself. Yeah, the air conditioner is ridiculous. It's like 38,000 BTU free drake in a room that's, like 10 by 10 feet. But it has to go to 2 rooms, which is why I use that one here. Anyway, let's see if I screwed up my camera angle. All right. We'll see if any bit of me is missing. So yeah, so I have it's missing PM Sleep S4L, and let's go over that. So, the first things first here is I do get a light on the charger, and the light in the charger means that I have PP3V42, I don't have to check that one. Now, if I was to go over to the screen capture here and show you on the schematic what's going on, let's open up the schematic for this motherboard, a list of all the rails. Now, PP3V42 is present because I have a light in the charger. The one-wire circuit wouldn't be working, and that wouldn't be working without it. So if I look for PP bus G3 hot, all right. So if you guys are new to these videos, I would highly suggest you start watching the old ones because I'm going to, in order to make this feasible, I'm going to discontinue some of the troubleshooting steps that I've taken in other videos. So one thing that I've really valued with this channel is that any user can click onto any video and immediately kind of become immersed in the troubleshooting. I try to get you inside of my brain to be a part of the troubleshooting process. The reality is that makes doing these videos incredibly, incredibly boring because I'm going over the same shit over and over again. I know how the board view software works. I know how to find PP bus G3 hot. If you don't know any of those things, watch the board repair videos in 2014 and 15 and even early 16 because I'm just not going to go over that stuff anymore. I'm just going to measure it on the board and get to the point. So let's see. PP bus G3 hot is, let's measure it. That's going to be the main power line. This fucking microscope light drives me nuts. I get 12.55. That's good. So we look back on the screen capture here. I know I have the DC in rail because if I didn't have the DC in rail, I wouldn't have anything else. The DC in rail is the rail from the charger. Let's see, PPV RTC underscore G3 hot. That's supposed to be 3.3 volts. That is important. Don't think that the real-time clock is only there for, telling time. Let's see, PPV RTC is 3.3. PP5VS5, let's take a look at that. So PP5VS5 is, it's there. And now we go to PP5VS4, which I'm going to have to look up where that is because I honestly forget. So here's where you'll get to see the board view software in action. Okay, I can look it up on this pin over here. Zero. So let's see what creates PP5VS4. So PP5VS4, let's go back over to the board view software. Alright, so this is responsible for PP5VS4. This is a buck converter. If you don't know how a buck converter works, watch my videos on that. So let's check. Now, I like to check the ends of the circuit, which has nothing. Now we're just going to check for a short to ground real quick, just to make sure there's no short to ground there. Go to resistance mode in the multimeter, put it in diode mode to get a quick measurement, put the red probe on ground, and without power being applied to the machine, put the black probe right here. No short to ground. So now we've checked the end of the circuit. Now, before we check everything in between, I like to check the beginning of the circuit. So EN1, you look up the datasheet for this chip. You don't even have to really do that, just common sense. Enable 1, enable 2. We have the enable for the power, the buck converter on this side. We have the enable for the buck converter on this side. So let's find out where our enable signal comes from. Again, I'm not going to check everything in between. I want to see where this enable signal comes from. This is where it gets tricky. So what makes this? Does this make it, or does this make it? So let's see where this comes from. Well, obviously, this can't be what's making it, because this is going through a no-stuff resistor that's not on the board to get here, right? No stuff. That means this is not here. If this is not here, then that means that this is irrelevant. So if R8176 is not present, then I don't give a fuck about P5VS4 RS3ND, because this is, again, it's not going to go anywhere. PM sleep S4L. Now, I'm not going to check the resistors in between and all that crap. I want to get to the start. I like to check the beginning of the circuit and the end. So it looks like PM sleep S4L comes from the PCH, so this is where this, quote-unquote, begins. What's with the transitions being slow as shit, too? Look at that. Like, I'm waving while I'm switching back and forth. It's kind of slow for a second there. Anyway, I'll figure out what the hell all this stuff is about eventually. So I'm going to look for PM sleep S4L. Now we're going to measure for it. Hi, where the hell am I? I'm in resistance mode, not voltage. What the fuck? And I don't even have the damn thing plugged in. Okay, let's plug it in. And let's try this again. We should get a much different result when it's actually plugged into the fucking computer. We get 0 volts. All right. This is where it gets a little bit confusing. So PM sleep S4L missing means that the PCH, this chip over here, is for some reason deciding that we shouldn't be getting to an S4 state. So there are many different things that can cause this. So if we look on the schematic over here, you need certain signals to be present, like PM bat low. If the battery is low, meaning when the signal is low, it's present. If the battery is low, which would happen if it's 0 volts, that's not going to work. That's not. If the SMC adapter is not enabled, if the adapter is not enabled by the SMC, it's not going to send out those signals. So the way this works for logical purposes is if you have everything on the input, you'll get everything on the output. PPV RTC G3 hot. Now this, being in the power management section, also gives me a hint that the RTC circuit has something to do with this. So another thing that can go wrong, the RTC circuit also pulls up several signals like RTC reset, SRTC reset, intervermin, and intvermin. Looks like Apple got wind of my ant problem. And PCH intruder L. A lot of these are pretty silly signals to have in a laptop. It's like, you know, if you open the case, alert us that the machine has been intruded into. Lots of stuff that's virtually or just totally irrelevant here. But those do have to be pulled up. Now, there are many other things that can also cause that signal to be missing, which is why I hate missing PM sleep S4L. It can be a BIOS issue, it could be a random corrosion issue, it could be dead CPU, dead PCH, it could really be anything. So let's just take a little bit of a tour of the board and see if anything seems relevant. Now, the original damage on this that was visible to the naked eye is over here. Keep in mind this board has been ultrasonicked by another store. Since it's been ultrasonic by another store, I can't even look for the green stuff. What I have to do is I have to try to fucking imagine where the green shit is. Now, the stuff that really sucks about getting boards from other places that have ultrasonic them first, I'm not trying to say this to really harp, and hate on other people. I'm just saying it as a fact, is that your only hint here, usually, is going to be where the corrosion was. So the way I often associate specific problems with specific areas is by just analyzing and trying to make assumptions based on where I see corrosion and where I see damage. And I talked about that in one of the videos and how you gain intuition. Now over here I can see that there's some stuff on the keyboard connector, but ultimately that doesn't really tell me shit. That's not really going to keep this the PM Sleep S4L low. Now the only thing that I could think of is that on the keyboard connector we have SMC on off L. So let's just take a look at the SMC on off L signal. Now this means that the power button is being hit when the signal is low. Now if there's some type of corrosion that's pulling that signal down, then it's never going to turn on. So the idea of how it works is that when you hit the power button, it lowers a signal called SMC on off L. It tells the SMC we've hit the power button, right? But if you hold down the power button, it keeps the computer in an SMC reset state. If the SMC is being reset, it's never going to tell anything to turn on. So let's see if that signal is high right now. Alrighty. So I can find SMC on off L on the board right over here. So 1, 2, 3 on the 5th resistor or on that little probe point. So let's try and find it and see what we measure. We're just going to follow the hints. Follow the hints. We're a detective. Follow the hints. What do we get? This is the only reason, to be honest with you, that I've been able to do this for so long is by seeing it like a video game or like a detective thing, Because it kind of becomes a game after a while, trying to solve all these different problems. And seeing it as a game is what kind of makes it fun. SMC on off L is 3.391 volts, which is high enough that I can kind of consider it good. But, do you see what I see? What is this horse shit? Well. Okay, now we're getting close. But now what we have to do is we have to try and figure out what is relevant and what is irrelevant, because we have corrosion in this area, and again, just like the keyboard connector, I've now determined that that corrosion is kind of irrelevant because it's not pulling down any signals that legitimately matter. But now I have to poke around and see if any of this stuff matters. So let me just get a pair of tweezers. I did mean poke. I am actually going to poke at some of those things because they look like they're falling off the board. This used to be a very common troubleshooting technique when working on really, 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 really old audio gear. I remember the way I would often figure out what was wrong with some of these Pultec equalizers, and they were all none of this stuff was made on a PC board. It was from the 50s, so it was point to point, like resistor, capacitor, capacitor, inductor, inductor, wire, and turret terminals and all sorts of old shit like that. What I would do is I would take a pencil, I would take the eraser, end of the pencil, and I would just start tapping things. And if something disintegrated, like actually disintegrated and just poofed and fell, that's what I would replace. And that was a pretty... I mean, obviously, that's a very obsolete method of troubleshooting. If I use an eraser here with a pencil, I'm going to touch, 30 components at a time and not one. But that being said, let's just go back here and take a look. Now, if I poke at this, it does have a little bit of a shit stain of solder holding it on. This has a little shit stain, but man, that is really a shit stain. Shit stain, whoa. So this is gone over here. All right, let's see what this is for. Let's see what this is for, and let's see what that's for. So let's see what those couple of things are for. So we're going to go back over to the board view software. SMC TCK, SMC TDI, SMC TDO, SMC TMS. So these are pull-up resistors, and the reason I call them pull-up resistors is because each one of these resistors is not in line in a circuit between one thing and another. It's not like between one signal and another signal. It's between a power rail and a signal. So that means that this is being used to pull up a signal, And these signals in this case is SMC TMS, SMC TDO, SMC TDI, and SMC TCK. Now, this kind of sounds a little bit familiar, so if you were just to Google that, I know what you're thinking. What the fuck is TCK, TDI, TMO, PBS, all this other horse shit? And trust me, I've been there with you. So what I'm going to do over here, TDO, TDI, TCK, we're just going to Google this. JTAG, technical overview. So it's something to do with using this as a test circuit. They should usually be disconnected. I'm going to be honest with you, I don't really have an idea exactly what each of those signals do. And we're at a point where I just kind of don't care. So the whole idea is the SMC TDI, TDO, TCK signals, those are all signals that are being used so that this will be... What was I just talking about? Are you fucking kidding me? You look like a frog so that you won't be seen on camera. I'm glad to see the new shoes are working out for you. So... For those of you who don't know, the camera's on top of the fridge, and an employee literally just like walked like a frog across the floor to not be seen on camera. Anyway, so the SMC, TDO, TCK, TDI, this is all used to put the chip or the circuit into a different mode when dealing with, JTAG, which is used for usually just testing and prototyping and shit that we don't care to look into today. Exercise. So let's just try to fix what looks fucked up because I lost my train of thought from that silliness. Let's get a donor. And what the hell, we'll even be nice and put some of this stuff back on. Like this over here. Let's see what that's for. I never actually checked. That's missing. So according to the board view software, SMC int L, it's all just stuff to set the mode. So since that's corroded and looks nasty and I don't really particularly feel like trusting it, let's dump this area altogether. None of this stuff looks good. None of this stuff is trustworthy. Half of this stuff looks like it's just going to fall off the board a day after I give it back to the customer. So it's all just going to get sucked up. So this resistor, that one actually looks savable. And that's for some unimportant sensor anyway. So let's just get those pads ready. Probably be better if I use my smaller iron. This is the T15 JSO2 tip on the FM 2027, which is, I would not say appropriate for this application. The FM 2032 is going to be far more appropriate for this application. With the T30-KN tip, it's also going to be a little bit better for my scraping motions that I like to use in these situations. Yeah, that's what I'm going for. There we go. Goodbye, resistor. I don't even care if you were good, but the way you look, you got to go. Okay, next. Goodbye, resistors that set TCK and PBS and SM and all this other bleh. That's the thing. Sometimes you don't really have to know what it does. You just have to know if it's related or important. Do I want the system management controller to be in the right mode? I probably do. Do I know what the modes mean? Not Really? Could I figure it out? Sure. Do I care to waste precious time and resources on it? Not really. I need to save that brain space. I need to use that brain space for stuff that's going to make me money. Not this horse shit. I don't want to become an expert on the modes of the SMC. You have to understand what is relevant and not relevant, and you have to understand and not be intimidated by the fact that some stuff is just not meant for you to understand. You don't have to know everything to get something done. You don't have to be a world-class chef to, fucking blend a banana. You just need to know how to hit the button on the blender and know not to put your hands in while the blender is on. You know? Trying to figure out what every single little thing does means that I will be qualified to fix this motherboard. After 7 reincarnations, sometime in 2582. Customer's not going to wait that long. Now here, I'm going to put the stuff on a little crooked and I'm not going to care. The reason is because I want to avoid using excess heat. So I'm just going to do it this quickly, and then at the end of it, I'm going to use some flux and then heat them all at once. It will all just come together. All I want to do is just get it so it's just on the board. All that stuff is on crooked, but you'll see what I do to touch it up. Another thing about this is every job in life is going to be about figuring out a way around your weaknesses. So a couple of my weaknesses is train of thought, memory, and hand stabilization. Yet I've chosen a career that requires constant analytical thinking, memorization of ridiculous amounts of diagrams and processes, and manipulating items and components that I can't see without a microscope. I know. Kind of like God's practical joke. But you gotta find ways to make it all possible. These are the ways that make sense for me. You'll find something that makes sense for you. Or maybe you won't have to because you won't suck at your job the same way that I do. Who knows? Now let's see if we have any change. The fan has spun. Now I am done. See that? Somebody in the last video said, Lewis, I want to believe you, but I can't see the fan spin. See that? That's me stopping the fan. Ew, it's disgusting. And then, bam. So there you have it. If the SMC is not in the right mode, that can keep it from sending signals to the PCH, or in this case, the CPU, because the PCH is integrated into the CPU, that will then keep it from turning on. So your PM sleep S4L missing can very well be from there. I don't know if I posted it yet. I don't know if I've even edited it yet. I hope I have. But I went over how PP3V3 SMC AV ref was actually keeping PM sleep S4L from going. I don't know if this is one I recorded and have to edit, one I've recorded and already uploaded, or one I didn't even record. Because sometimes I do these repairs without recording them. I hope I did, because that was a really genuinely useful video that I feel may actually help people. But yeah, if the SMC is not doing what it's supposed to, it's not going to send those signals to the PCH. Again, if we go over this page, if we go to this page where I was on before, what page was I looking for? Okay, I forget what I was talking about, but I know when I see it that it's going to come back to me. So I'm just going to keep searching. And eventually I'll see what I was thinking about. Here we go. If you look at this page, it's just, again, I don't want you to think, when you look at this, I don't want you to think that, like, I need to know what DSW vermin and sysac and blah means. I mean, you can look that up. Again, Intel does release a document. It's about 600-700 pages long. I go over it with everybody that came to Practical Board or Periscope, and I was going over what a lot of these signals mean. But at the end of the day, I want you to look at big picture. I want you to be big picture thinking. What is going on when I look at this page? Not little things like clock run and Purdon and all this other horse shit. What is the main thing that you see when you look at this? It says system power management. All the ins are on the left. See all in. Well, there's one out over there, but fuck that. In. And then on this other side, you have out. What do you think has to happen here? When the signals come in, then the other signals go out. So where do these come from? Oh, they come from the SMC. Let's look at my SMC. Oh, there's a bunch of corroded shit on it. What is it around? Oh, that stuff is around tick, to me, and I mean, it's around SMC TMI. What does that mean? I don't know. What does SMC? Let's look this up and see. What does SMC, TMC, or TMI, or TDI mean? It means too much information. Stuff that you don't need to care about. You just Google some of that stuff, and look, what does it say? It says that has to do with the mode that it's in. I'll run with that. I'll go with that. I'm not going to have to say, okay, what mode is the SMC? What are the different modes of it? No. Let's just stick to common sense here. It's meant to pull up the signal. If it doesn't pull up the signal, the SMC will be in a different mode than it was before. I don't know what the names of the modes are. I don't know what the different modes of the mode types are, but you know what I know? When the fan doesn't spin, that's SMC underscore fucked. Right now, it's an SMC underscore fucked mode. So I'll take any one of these TMS, TDO, TDI, TCK things over where I am now. I have nowhere to go but up. So we'll start there. Now it works. Again, a lot of people say I try to pass myself off as some genius, and that's how I know that they don't watch the channel. The whole idea here is to dumb this stuff down to where a 9-year-old could do it without having any real formal education. I want you to be able to look at this and not be intimidated by it. I want you to look at this like it's like with big picture thinking, and just fucking own it and conquer it and be happy to walk away at the end of the day with something that works without having to understand what every single little detail here does. You have to understand some of it. You have to understand the big picture. You have to have the big picture thinking. But I don't want you to think that you have to understand everything. Because if you think you have to understand everything, then you'll start fixing boards just like me in the year 2583. But that's it for today. And as always, I hope you learned something.